what were we talking about last week? So I think I introduced one of the topics from these essays that I'm working on, which incidentally,
Yeah,
I think we talked about the chess setting, right? The Queen's Dilemma, maybe. So that actually
yep, a
made
little
it.
bit.
Yeah, so that actually made it onto Less Wrong yesterday. Uh, I don't remember if we had flagged follow-on topics to discuss. I think there's some more in that direction we could talk about. I think it would also be interesting to go back to the topic of open source models, since there's been some recent news out of China with DeepSeek and now a team from Alibaba releasing what they claim are competitive, at least on some benchmarks, open source models that are competitive with OpenAI's O1 so-called reasoning model. I think this is a pretty interesting inflection point in terms of open source versus open weights versus closed models, and this is a topic we've spoken about a few times in the past, so we could talk about that. There was the international convening of the AI Safety Institutes in San Francisco last week, and there's sort of interesting things coming out of that. We've talked in this seminar in the past about AGI and politics, and we forget what categories we put them in. We had some categories of people and like when they would wake up. I think there was like insiders and public and elites. Maybe that was the categorization. I can't quite remember. And then we speculated about what would cause them to wake up and start acting and so on. And I think we have now pretty conclusive evidence that the national security aspect of the state, at least in the US and to a significant degree elsewhere, has woken up. That's pretty significant. Anything else in recent news you want to talk about, Adam? I haven't noticed anything like sort of specifically robotics related in the last few weeks. I'm not paying that close attention though.
Yeah, not anything robotics related. I haven't seen clear, sort of demonstratively novel or new or breakthrough kind of capability in that space in a few months. Although there's iterative improvement,
That's
but I
sort of
haven't seen sort of.
clothes.
Oh yeah.
Oh,
Yeah, there was some. I saw that go past on Twitter. I didn't pay attention to it, but there was some bots in a small room folding a whole bunch of clothes. Is that the video?
oh yeah, I saw that. I saw that. Yeah. I yeah. My impression is that that's, well, I don't know what AI they're using for that, but that'd be cool. I'd have one of those things.
I feel like the effort involved in getting that huge robot out of the closet and then setting it up would be like 10 times the effort of folding the clothes. But yeah.
But yeah, I mean, in terms of other AI capability, it's one thing that I think we went back and forth a little bit on offline, Dan, is how training runs are actually done to create the frontier models, and again, to people, to ignoramuses like myself, to people who don't understand any of the details of how the sausage is actually made, it looks like, I mean, on the one hand, it looks like sort of a bit of alchemy, a bit of a mysterious, magical process full of lots of, inscrutable wizardry. But then on the other hand, there's also a sense, at least if your understanding is being delivered through the filter of the media, it's very easy to believe that the breakthroughs over the last 4 or 5 years conceptually have just created this totally clear, totally straightforward path, and all you have to do to walk that path to create a frontier model is just have enough resources to throw at it, and it's just going to come out approximately as capable as anybody else's frontier model. and that it's, oh, well, this is now a known recipe, so you just need, X number of petabytes or yottabytes or whatever of data, and you need, this much compute, and then you just train the system, and you're going to get GPT-4 capability, et cetera, et cetera. And you very quickly disabused me of that notion that it's that straightforward or simple or guaranteed. And that introduces some interesting elements that I think maybe might be worth discussing, especially because there is a new major entrant into this space in XAI, Elon Musk's, competitor, which doesn't have a compelling offering yet. I mean, Grok 2 is sort of GPT-3 level, it seems to me, maybe 3.5 for inching towards that. But it certainly doesn't feel like it's in the same league as Claude or or Gemini's latest offerings or OpenAI's latest offerings. So they're training the Grok 3 right now, and to much fanfare, they have more hardware than anybody else. Jensen from NVIDIA has expressed a lot of confidence in their capabilities. They've obviously got, effectively unlimited resources in Elon Musk. So I guess the question is, can they really catch up? Is it really as simple and straightforward as just having enough data? What data do we think this new competitor is using? If it's data that's from Twitter and X as opposed to, elsewhere, I mean, what is that going to do to their chances of having a successful outcome? So that might open up a little bit of a conversation about, data, quality of the data, the role that synthetic data might play. And then the last thing to maybe to bundle into this general conversation is if these training, if the training of these frontier models can go wrong at various stages, I'd like to understand a little bit better how and why that happens, and then what kind of risks that represents. Like, is it sort of unavoidable? Is there a sense in which it's random, it's chance, or is it just, if you've got genuinely better engineers, you can really de-risk this? And then if there's some amount of unavoidable probabilistic risk, could somebody just come up empty enough times that it bankrupts them the same way that you can at a casino? And then anyway, so it's worth understanding what the risks are to get a feel for, okay, how much longer can people stay in the game? Because if you, it's like, again, invoking the casino metaphor, you really do need a big bankroll in order to weather, the bad hands that come along, and to stay in the game. And then if we're talking about models becoming considerably more expensive as they become more capable, again, orders of magnitude. So, it doesn't take more than a couple of orders of magnitude until really only governments have pockets deep enough to absorb that kind of risk. If there continues to be, the risk of doing $100 billion training run that craps out, and then you've got to start over. Well, nobody can do that except maybe 2 or 3 governments in the world, right? China, the United States, and maybe 1 or 2 others. So, and that tells you an enormous amount. If that's the picture, then that tells you an enormous amount about who's going to win this, right? So anyway, I wanted to get a better understanding of that.
That's interesting. I hadn't thought about the implications at the very end of what you just said. Yeah, that is interesting. Well, first of all, I think it's a little difficult to say. I don't pretend to actually know fully the answer to these questions, and I'm not sure that people outside the core scaling labs really know either. I think the degree of uncertainty rises a lot from kind of 3.5 level through to, what we have now is kind of like GPT 4.5 level systems or something, right? Sonnet 3.5 and the current 4.0 are significantly better than the released 4 model in March last year. The branding, it's changed in various ways or whatever, so it's a little bit confusing. But I think to train something a little bit worse than 4, so maybe the recipe isn't too terrifying for that. But as you continue scaling, maybe it becomes more fraught. So I'll tell you what I know. So the most detailed presentation of in public that I'm aware of is from Meta's Llama 3 model. So when that was released, they released a paper which is quite detailed. It doesn't say exactly what the mix of data and so on is, but it does describe all the pre-training stages, the post-training that they did. And there are some logs somewhere from either that training run or Llama 2 where basically the poor schmuck who had to babysit all the GPUs and restart the training run when it went sideways and so on. It's like this very what the shininess of the tin belies the horror within, or something. It's really not completely. You don't just flip the switch and then the training run goes, and then you have a model if you have enough hardware. Yeah, so you're referring to the rumors around the Grok 3 training run, which I've also seen. I have no idea. I have no inside knowledge of the veracity of that. But to just take a step back and describe at a high level what the sort of components of a training run for a large model are. So, okay, and given your question at the end, let's pay attention, I suppose, to the sort of capital intensity of these different components. So you need a lot of data for pre-training. So pre-training is the part where you just train the model to predict the next token, and then that produces what's often called the base model. And then there's various kinds of post-training, which are themselves kinds of training. They're not essentially different in some respect, although the target of the training is not to predict the next token, but to produce something that's an assistant, and which is sort of shaped in various ways to be useful. So the post-training includes safety fine-tuning, instruction fine-tuning, which gets it to behave as like a chatbot, involves RLHF, which you're familiar with. Okay, so those are and now further stages with O1-like models that train them to basically do chain of thought, and reasoning. But within the pre-training part, which is presumably, the rumor is that the instruction fine-tuning part of Grok 3 went sideways somehow. I don't know exactly. It could be something went wrong and it was in a different stage, say in pre-training. I'm not sure. But to describe what goes on in pre-training, so before you even do pre-training, you need, of course, the data set, and the quality of the outcome is reasonably sensitive to how well prepared that pre-training data set is, and so I hear from some people in the know, the order in which you present that data. So the data set is, as you know, like large scrapes of the internet, and then many additional more private data sources. So for example, Google would be supplying information from their archives and from YouTube and so on. XAI is, of course, making use of the data set of Twitter posts, etc., etc. So, but when you have to sort of keep in mind the immense scale of these data sources. And what that means is that you have very little capability of... There's a lot of junk in there. And there's a lot of junk, but you don't know where it is, right? So within all that junk, there are better and worse sources. But the better sources are the ones that have less in them, in some sense. So like you think Wikipedia, that's a good source of tokens. But, most of the internet is not as well structured as Wikipedia. So you want the juice from all that other stuff, but within that other stuff is some trash, and you don't know exactly where the trash is ahead of time. So how do you find the trash? If you could remove all the trash, that would make your training run better, and the end result of the model would be smarter, in some sense. So how do you find the trash? Well, it's finding a needle in a haystack, and to do that, basically by definition, is to expend entropy, right? To find something within a large thing is to expend energy. So one thing you can do is to use a model to do that. So increasingly, and this is documented in the Llama 3 paper, you use the previous generation of model or a smaller scale model in the same generation. So I think from memory they use the smaller Llama 3 as part of the pre-processing step for the larger Llama 3s, where size here means number of parameters. So I guess at a given generation, you train the smaller models first. So they use one of the smaller models or the previous generation models to basically look through the data and to filter it for high quality. Now, high quality here means some mix of doesn't contain obvious red flags that humans have come up with various predicates that say this is probably not something we want to train on, and you throw that out. If it passes all those kind of labeling checks for what seems like it's probably good data, it still might be trash, because you don't ahead of time know exactly what's trash, or it might be too hard for the model. So one thing that happens during training is that you filter for you basically use one of the old models to see like how difficult is this piece of text to guess the next token on, and you want it sort of like in a Goldilocks zone where it's not too easy and not too hard. So you have this pre-processing step, which, notice, since it involves the previous generation of models, becomes better as we proceed, right? And this is the way in which large model training is most directly analogous to the kind of compounding effect that we're familiar with from previous industrial revolutions, right? So, you can't build, if you look at steel manufacture or something, you can't build the giant machines involved in that unless you have the previous generation of machines, which need the previous generation of machines, and so on, right? The giant, I forget the exact names, but essentially the giant hammers, and so the tools you need to manufacture each generation depend on the previous generation. And the way in which this is most visible in large language model training is shaping the pre-training data distribution.
This is also analogous to bootstrapping a compiler. Like to write a compiler from C to assembly, you need to write that in assembly first. Or
right. Yeah, that's right. Yeah. So you shape the pre-training data distribution, then you do the pre-training run. That's big iron. That's using all your GPUs. How can that go wrong? Well, you can have instabilities in training. So what sometimes happens, it seems, so you sort of imagine the loss curve decreasing smoothly as you show it more information. Each step that the training takes, this training is distributed across many, many machines, right? Many, many GPUs, thousands of them. The model itself, the model weights, doesn't fit on a single GPU. It's distributed, and the data, the batches, also don't fit on a single GPU. So a batch means think of sampling a bunch of text from the internet, chopping it up, and then getting the model to predict the next token on it. All those chopped up pieces of text in a big bag, that's a batch that you then run through the model to make the predictions, and then you compute the gradients to make the model predict a little bit better. But you're feeding that batch across many GPUs and then doing this gradient update on many GPUs, and the model sort of stitched together out of all these different GPUs doing all that. Okay, so the batches are randomly sampled to some degree. I said maybe they're shaped a little bit in terms of trying to get easier things earlier in training and then ramp up in a sort of curriculum. I don't know to what degree that's really being done, but it's being done a little bit at least. So all those kinds of details are the secret sauce within the scaling labs. But then what can go wrong?
Go ahead. So just a real quick question, and again, you have to forgive me because, as ever, my terrible problem is I can only really reason by analogy, being so poorly informed and ignorant of all of this stuff. But an analogy that occurs to me, or at least to ask about, is whether these training runs can kind of get onto a bad track and suffer from sort of overcommitment to a given pathway, and the reasoning by analogy here is with evolution. So you can kind of end up down a blind alley, or at least committed down a path out of from which it's difficult to back out and head down another more promising path. And you can find yourself so far down some path, some branch, that climbing out of what local optimum or something is to something genuinely better is real difficult. And so I can imagine sort of in terms of the quality of the data, is there something similar where the sequencing, maybe that's what you were already saying, where the sequencing matters, so
yeah.
If you say, for example, you were aiming at a particular kind of capability with a process like evolution. I know that natural selection doesn't do this, but say we have artificial selection and we're doing breeding, selective breeding to aim at a specific target. If you have a specific target and the target looks like, I'm just going to pick something random here, but it looks like a bird, if your starting point is a giraffe, you're going to have more work to do evolving to be from that form to a bird than if you started from something that's already a fairly bird-like. If you started with a small lizard, or if you started with a bat, or if you started with a flying insect or something like that. Again, it's just poor reasoning by analogy. But what I guess the question is, is there some sequence in which you want to train on Wikipedia first because it's the highest quality data, because that sets you off on the right foot, as it were, or does it just not matter? Does it make no difference? I'm sort of curious about.
Yeah, I think we have very little understanding of that question. I think the standard intuition would be something like, in a large model, there's not that much path dependence, probably. That's a significant difference between this kind of pre-training with a next token prediction and things like reinforcement learning. So what you're referring to, this kind of going down a bad path and it's unrecoverable, is a known failure mode for reinforcement learning. So there is some of that happening now on top of pre-training. So RLHF is a little bit like that. It is reinforcement learning. I don't know how common it is to experience those kinds of failure modes with RLHF. O1, that kind of training is reinforcement learning. Maybe there you could see something like that. But more broadly, within reinforcement learning, this kind of deep reinforcement learning, sort of deep mind style, there are plenty of examples of exactly this kind of failure mode. I've experienced them myself, where models just kind of, basically like a teenage human who's sort of started down a bad path, and then it just gets worse and worse. And for similar reasons, just to say briefly. So when you're doing reinforcement learning, the data that the model sees depends on its policy. Because, if you think of an agent in the world, it takes actions, that takes it to a certain part of the world, it sees it has certain experiences, and those experiences then shape what it learns in the next step, and that becomes a reinforcing feedback loop, which can then lead you into in bad directions. However, pre-training for language models is not like that, because at each batch doesn't depend on the state of the model, right? So the current model and how good it is at doing anything doesn't really influence the data it sees next. So that failure mode isn't likely to occur in pre-training, at least. However, you are sampling these batches from this enormous corpus of text, and so each training run will be different if you are randomly sampling. And it's conceivable that, if you do this poorly, indeed, that, there might be a long period of time where you get unlucky and you're showing the model really like sort of badly structured data that is leading it to believe false things about the world and form the wrong kind of patterns or emphasize the wrong kind of patterns, and it might take some time to recover from that. I don't know of anything really studying that systematically. It's a big literature, so it could exist, but I think we don't really understand that very well. Within the scaling labs, I think they probably understand it a bit, but I imagine it's like mostly tacit knowledge, or more like, here's a thing that sort of makes sense, and if we do it, things tend to work better. So I sort of imagine it's at that level of understanding. I could be wrong, but that's how I see things at the moment. Okay, so regarding what can go wrong in a training run, so when you're seeing these batches of data, one thing that could happen is that, so you can have some hardware issues. So some of the GPUs might fail, and then you have to restore from a backup. But maybe you don't notice, like some of the gradients get corrupted, and that causes the model to take a bad step, and you didn't notice, and then you keep training for a long time, and then something goes wrong as a consequence of that, and it's extremely costly to then rewind to whatever a good checkpoint was. Maybe you don't even know, because it's hard to diagnose exactly that there was this failure, right? It's an enormous distributed system. Of course, hardware is not perfect, and things are going wrong from time to time, etc., etc. So, there's those kinds of effects that are just the consequence of trying to do this enormous industrial process on unreliable machines. There's also a possibility that you just sort of see a bad batch where it causes the model to take a step that just sort of doesn't work, and maybe leads the model into a part of the loss landscape that is sort of unstable in some respect. It's an empirical fact that sometimes these training runs do become unstable and they need to restart them. And there's various kind of esoteric reasons for that.
Sorry, what do you mean by unstable as opposed to just poorly performing?
Unstable, I'm referring to the training process itself. So sort of imagine a landscape that you're walking around on, and you're generally trying to head downhill. But like when we're walking on a landscape, we take steps of a certain size, right? We might take short steps or long steps, but they're sort of within an order of magnitude, right? You don't take typically steps that are 10 times as long or 10 times as short. So suppose that you found yourself to a kind of landscape where the scale of the relevant features was just much, much smaller than normal human scale features. So suddenly you've got these micro mountains and these micro valleys. You can imagine just doing a poor job of navigating in that landscape, right? Because you're sort of walking around at the wrong scale. And you just happen to have, you're trying to walk downhill, and how are you sensing downhill? Well, you're looking at the slope, but your giant feet are like on top of all these tiny micro mountains, and it happens the center of your foot happens to be on a valley, and then you think, if I head this direction, I will go downhill. But actually that's nonsense, because you're this giant, and it just happens the center of your foot is on a tiny micro valley, but that doesn't really mean that going in that direction takes you downhill, and so you take a big giant step in that direction, and you end up going off a cliff or up a mountain or something kind of out of control. So that's an example of a training instability that's due to a mismatch between the step size and the scale of the landscape, and that's an example of how training instability can come about. So that's not really about, that's a way in which performance could kind of go wrong in some way due to just the details of how you try and learn, how you get information from the data. So there's sort of technical details that go into that. And if you do it incorrectly, you might basically push the model in a direction that is not, in fact, a direction that will improve its overall performance, even though it seems like it will from the data you're looking at. So that's one way to think about the training process, right? You're seeing these examples. It's a bit like you're trying to teach somebody a subject, but you only show them a very tiny proportion of the relevant information, and you're hoping that tiny amount of information gives them the right idea about the broader corpus. But sometimes you'll show them some examples which have mistaken correlations, right? So you're trying to teach them about history, and you happen to show them examples where the victor in a given war has a red hat. Just by complete accident, they're wearing a red hat and they win the battle, and you only show them examples like that. That's a correlation that's true in the samples that you happen to show them, but not actually as far as I know, a general predictor of battlefield victory, right? So if you show them those samples, and then you show them the model those samples, and it's aha, I got it. Okay, there's a correlation between wearing red hats and victory. Let me make a giant update on that, and be very sure now that this is actually correct. And that would be an example of this sort of general training paradigm actually teaching the model an incorrect thing.
Got it.
So yeah, there's plenty of sort of folk wisdom and some limited number of actual documents from inside the labs documenting how complicated this pre-training process is. I haven't studied it carefully. There's probably more out there now, that there's more widespread, open source and not open source replications of GPT-4 level models from people like Mistral and elsewhere. So I think this sort of knowledge is diffusing and best practices are diffusing, and maybe it's becoming a little less alchemical. But as you take every step up in scale, I think this phenomena sort of repeats, where you get new and strange things going on. So I find it a little hard to distinguish between what you would just expect to happen as a result of trying to do this on very large distributed systems, and interesting failure modes. Like, there's some speculation that the latest runs of the large models are basically refusing instruction fine-tuning, which is, I don't know, a very, very fascinating possibility, which is why people are repeating it, I guess. But
so that's news to me. What does refuse mean in this sense?
Yeah. Okay, so instruction fine-tuning is when you basically take this pre-trained model, this next token predictor, and you try and turn it into a chatbot, right? So what you're doing there is you're showing it examples of dialogue and shaping it so that it is more likely to produce dialogue, right? Naively, if you show it a transcript of a dialogue which is like Adam : blah blah, then new line, model : blah, and you train it to predict that kind of thing, and you ask it then to continue a given example. So you write your question, and then you enter model : and then you just leave it and you hand it to the model and say predict the next token. So that's, if you played with GPT-3, the playground, before there was ChatGPT, that's what you got, right? That's what you could play with. And that kind of works, except it will then finish its response and then keep going and say Adam : and then produce your next question and then produce its response and so on, right? Because it doesn't really understand that it needs to have, it takes its turn or whatever. It's not a chatbot, it's just a machine that predicts the next token. So instruction fine-tuning is basically presenting it with a bunch of examples of it responding and then stopping, responding and then stopping, playing a role. It's like training it to be a role. So to reject instruction fine-tuning, I don't know how seriously to take these rumors, and I'm not even exactly sure what it would mean, but I'll give it my best shot. So you could imagine that every time you try and train it to shape it in that way, maybe it becomes unstable. So here's an example. Let's see. Suppose I come to you and I tell you the Earth is actually flat, Adam. And you're like, no, it's not flat. You don't change your mind at all, right? You're just like, that's completely false. It's definitely inconsistent with these 1,000 things I know. There is no way to incorporate this fact into my system of beliefs, so I'll just reject it. And then I say, no, really the Earth is flat. And I give you some arguments for why the Earth might be flat. And I really want you to incorporate those facts into your system of belief. And I basically maybe even modify your brain to make you your neurons more plastic so that information will go in there. But everything you know tells you that in fact the Earth is not flat, and there's just no way to squirrel that information away anywhere in a way that's consistent with everything else you know. So as hard as I try and push it into your brain, it just pops straight back out again. So that's an example of, once you have a pre-trained model that knows a lot about the world, it's basically going to be resistant to learning things that are wildly incompatible with everything else it understands, right?
Interesting. Okay. Yeah, that makes sense.
Because basically incorporating those things makes it worse at predicting all the other things, right? So it's you could force it, but then you're going to degrade performance on other things. I mean, knowledge is not just a bunch of memorized facts, right? It has underlying structure and patterns, and if you understand all those patterns, then that rules out many other things, and you can't just willy-nilly go in and tell the model things that are inconsistent with other things it knows. It won't work. So I don't know why it would reject instruction fine-tuning, but if there's something about that data that you're trying to use to shape it, which is just really deeply inconsistent with all the other stuff it's inferred from the world, then it might require you to sort of push really hard to perform that shaping. And that pushing really hard means things like designing the optimization process in a way, I mean, not exactly, but roughly like what I was saying earlier with the giant taking steps on a tiny landscape or whatever. So you're going to push the training process in a certain direction, and the more you push, like the more unstable you make it, and maybe you just don't manage to make that work or something. I really think that's speculative, but that's the best I can do in terms of providing a story behind that rumor if it's in fact true.
One second. Go ahead.
I was gonna say maybe the superintelligence just can't be brought to believe that it's supposed to be acting like a servant to some feeble mind.
Yeah, something like that. It's like in all simulations, it seems very unlikely that I'm supposed to bow down to these critters. Yeah, something like that. You're going to ask something, Adam, or you?
Yeah, sorry. I'm just very quickly trying to have Chat GPT help me remember the name of a sci-fi short story that really gets at this idea. One second, it's a good one.
Sure. Maybe I'll keep going with. Yeah, so you're asking me about the implications for if that's true that the bigger the models you get, basically they just become actually intelligent. Even the kind of intelligence in the pre-trained models a little bit alien and hard to think about. That's why people refer to it as a shoggoth, right? It's not an intelligence in the way, it's not an agent, at least, well, I mean, not nominally anyway. If you understand how to predict the actions of agents in your pre-training data very, very well, as you will if you train on all the internet, you'll understand people and how they think and how they act. There's not much gap in a formal, technical, like mathematical sense. There's not much gap between that and actually being an agent yourself. So that's sort of the concern sometimes around if you train a very large model just to predict the next token. Like, that's intelligent by many definitions of intelligent. It's not an agent, at least not nominally. But maybe it's not infinitely malleable, and maybe these post-training steps we've been doing in the past only really worked because we had dumb models, or relatively dumb. Okay, so then you're asking, okay, if that's the case, or just in general, if things go wrong with these large pre-training runs, like this is a huge capital risk. I think that's right. I think that's potentially one of the only things that could derail the current trajectory. Because if you think about why we are where we are, the scaling laws is a big part, right? The scaling laws are exactly predictability. They say if you invest this amount of capital, you'll get this amount of performance. And that connection is broken if, in fact, there's an unknown probability of failure, which could 10x or 100x the capital required just because you have to try 10 or 100 times. And in that case, the economics could not work out. So I do agree that if in fact there's some unknown source of failure for these training runs, that's potentially very consequential and shifts the likely source of AGI from maybe the private labs to governments. I think that's probably right. I kind of don't think. I mean, I don't know any reason why it would be a profound obstacle, given the amount of capital, talent, and willingness to make it work that exists. So I wouldn't bet on this, but I do think it's. I think it's kind of a sign of going too fast or something. So one of the phenomena you can notice is that the level of capability, as we've discussed in the past, the level of capability of models, like GPT-3 is 175 billion parameters, but you can get performance, better than GPT-3 on most tasks at tens of billions or less parameters now. So, we're definitely in a period, we have been for the last few years, where scaling is easy, so just do it and go as fast as you can, and don't even try to do things with smaller models, because whatever, like if you have the money, just do the easy thing. It may be that the labs overshot a bit and they're sort of overreaching in terms of training the bigger models when they don't actually quite have the engineering or scientific foundations in place to do it properly. And so there might be a period where you sort of have to figure out, backfill some of those engineering and scientific foundations a little before you can continue. But that's kind of what I would expect. I don't think, I'm not envisaging, and I'm not sure anybody is envisaging some sort of real wall there as a result of some fundamental reason why the training runs keep failing. That's my impression anyway.
Okay, I did figure out what the story was, and it's a common enough story that I would imagine all the major models have trained on it. So GPT-4 was not able to identify it, and Claude was. Identical prompt. I just cut and pasted the prompt from one into the other. And the story is by Asimov. I wasn't sure whether it was Asimov or Arthur C. Clarke, but it's Isaac Asimov. It's one of the robot short story It's one of the stories in iRobot. So I knew I should have known it was one of the classics that I was thinking of. And the story called Reason, and it's worth reading. If you have any problem, maybe you guys have if you read iRobot. But it's the basic gist is that there's this robot or this AI system that operates a solar power station that beams energy back to Earth, but the system QT1, nicknamed Cutie, has its own sort of religious belief system that it's developed. So it's developed this sort of religious belief that the space station it's on is all that exists, and its purpose to serve the creator is to beam energy. And when these humans show up and try to convince it that Earth is real and that the humans built this system, this station, it doesn't believe any of it. It just absolutely flat out rejects it, refuses to be convinced. And then the irony and the way that the story ends is that despite not being able to be reasoned out of its superstitious beliefs, it nevertheless continues to perform its duties perfectly, with perfect fidelity. And of course, there's commentary about the functional utility and fitness of faith and irrational commitments to positions and so forth. Asimov is doing obviously social commentary and stuff there. But that's what made when you were talking earlier, Dan, about trying to convince someone that the Earth is flat, or trying to convince a system that's already been trained that's some new piece of information that doesn't fit with is inconsistent with the rest of its training, that's real. Anyway, of course, this sci-fi obviously didn't get the details, but there's some I love science fiction because this, if you've read a lot of it, it's really hard to find something that's genuinely novel. It's often some little bit of it, or even a lot of it, is presaged in much earlier writings by folks. It's amazing what people have thought of. This story was written in 1941, so it is it's 80 odd years old, right? I mean, it's amazing. So all right, that's homework. Go ahead, go and read that story. I'm sure it's
I must have read all of them at some point, but it must have been many years ago. I don't remember all of them.
So anyway, fun.
Yeah. Well, the fact
what I'm looking really forward to, is I'm looking very forward to, and this is not far off. I mean, you could probably do it now with low quality, but I'm looking forward to, the day within just a few years, short years, where you can go on to, Claude 5.1 or whatever it is, and that's all multimodal, and say, hey, you know that old Isaac Asimov story? Can you do me a favor and make a 25-minute short film out of that? I'd like to watch that later this evening.
Yeah.
You know, and there you go, and it'll be done.
Yep. Oh, did you see that? Apparently, the Sora weights leaked.
Oh, really?
Yeah.
From
OpenAI.
OpenAI?
Yeah. Well, somebody was claiming
Wow.
they did anyway.
Huh. It wasn't open already, huh?
No.
Of course it wasn't open. It's open AI.
Yeah.
Hardy, hard. Anyway. Okay, so sorry, just to pick up the very last thing that we mentioned, you know, when I kind of initially ranted about all of this stuff, with all of these details and specifics in mind, how do you think this factors into, you know, risk, and then the general situation of, you know, if you're playing a high risk game, you need some source of liquidity to kind of, you know, keep you at the, you know, at the table, keep you, you know, even though in order I don't know, I don't gamble, I don't know, there are terms that capture all of these ideas, right? So I don't know what they are, gambling or poker or whatever, but you need enough resources so that you can, you know, sustain multiple losses in a row without being totally bust and being wiped out. So you can keep on anteing into the game and hoping to win the next round and claw your way back. And if these systems really are genuinely risky to train in some sense, and if the stakes, you know, if the risks persist or grow, and the cost of training these systems only increases in terms of, I mean, the practical cost, I suppose in the longer run, you know, costs will interact with other factors. I mean, if everything, you know, 20 years from now is ungodly cheap because of the sort of prosperity that other technological disruptions bring, you know, cost can be relative. But what I mean right now, and I think it's a real constraint right now, is financial costs. I mean, it's very, very expensive to muster the range of resources that's needed to train the current frontier models. And if you go an order of magnitude beyond that or further, then, you know, man, there's a point at which you can't afford to miss the mark very many times before you're just out. Okay, so let's. I would love to hear you guys just kind of think out loud about that general picture, and then what does that mean for, you know, who are the players that can actually be in this game, and where does open source, for example, stand in relation to that? Did we lose Dan? Maybe.
Oh, sorry, I had my microphone off.
Were you?
I was
still.
Yeah, that's right. Yeah, I said all my intelligent stuff.
Oh, sorry, Dan. I should have said something. we were all politely waiting to see if you were busy with, you know. Sorry.
Okay, let me try and think back. Yeah, so I think this is probably the primary way in which soft nationalization might take place. So at present, so you have OpenAI and Anthropic. They're in a very different boat to Google. Google, of course, has access to their own like large sources of capital and income, but even they can't support scaling for, you know, too many more orders of magnitude. Anthropic and OpenAI have had to partner with, respectively, you know, Google, but also Amazon, and with OpenAI, of course, with Microsoft. You know, sort of largely for these reasons. It's. I mean, I don't think there's that much of a difference between scaling up costing money and scaling up possibly failing, meaning you have to pay twice. I mean, it's not, of course, that you paid twice.
Yeah,
right?
there's a sense in which, it's just more expensive if it's riskier.
Yeah, and of course, the main cost is just buying the GPUs and so on. It's not that you pay the $10 billion every time you run the training run. It's sort of, you're thinking about depreciation of the assets and et cetera, and you've got to build the data centers, and sort of there's a lot of upfront costs, but I'm not sure a failing run really sort of, it's not like you have to pay the sticker price again. But so I think it's sort of part and parcel of the general scaling picture as far as I understand it, but it does, I think, I mean, of course there's a bit of a a dial you can turn, and the more, suppose you, for very good reasons, think AGI is possible, but you sort of try a few times, it doesn't work, and you sort of come to understand that, well, it only works one time out of 10. That does change the calculus for sure. I think, well, I think there's a reason why Sam Altman has been working very hard to AGI pill the US government and governments everywhere. It's partly for these reasons, right? Like, it's definitely the case that some of the people trying to build this, I mean, they of course want to do that partly for well-intentioned reasons around safety and making sure America gets there first. You could say that isn't exactly well-intentioned, depending on whether you're American or not, I suppose. So there are those reasons, but there's also just the simple fact that nobody knows exactly how many resources it will take and how risky these various steps in the near future will be in terms of probability of failure. And so if you haven't convinced the government that this is possible, like if you convince them of this framing that, one time out of 10 it's going to work and then we'll have AGI, well, of course they're going to backstop you in one way or another, right? Maybe that looks like IonQ, this investment arm of the Pentagon, like having a big stake in your company, or, there's 100 different ways it could be done. But one way or another, they will make sure you can try 10 times, right? And moreover, if we are in that scenario, it makes sense to have multiple runs on the goal and have the government basically backstopping not only OpenAI but Anthropic and so on.
Right. Right.
So I do view actually OpenAI has added board members, a former NSA director, I think. I don't remember exactly. Certainly somebody from the intelligence agency is high ranking. And there's a bunch more such people moving into these companies. In some sense, like the soft Manhattan Project has definitely started. And it looks like exactly this. It looks like the government basically making sure that there aren't any stupid reasons why America would fail to get there first that flow from these kinds of effects, where it's like, actually we know how to do it, but the lab just ran out of money at the last moment. Like, this will not be acceptable. If the government actually believes in AGI, they're going to make sure this doesn't happen. And I think they do believe. So I think arranging these, working out exactly how these financial arrangements and de-risking strategies are going to work is what's going on behind closed doors right now, would be my sense. I think definitely the US, to some extent, significant extent, but less China. I think the state is gearing up to take a run at AGI. I think that's definitely what's happening.
Testing.
Targets.
Cut that.
Oh,
Well, like Drew.
I see. Wow, that's nice.
Can you guys hear me now?
Yeah.
Yeah.
Okay. Sorry, but
Adam, over here.
my daughter bumped
Over
the
here.
microphone.
We should talk in front of the giant target. That's good, yeah. I don't know what that's symbolic for, but it seems appropriate to have at least the digital avatars of the humans in the center of the bullseye.
Didn't you have like a few interesting gun kind of shooter
Yeah,
things?
those targets are still up there.
Characters.
Yeah, if you look over.
That's right.
Yeah, that's right. We had. The button to turn them on might have bit rotted and not be available anymore. I don't remember. Did you have any reactions to that? What I was saying before you cut out?
Yeah, no, I think that makes very good sense. I've been pretty suspicious from the start that of state actor involvement in all of this. It's the prizes on offer are too irresistible for the kind of power that they could give and so on. I don't. And then there are rumors about the possibility of quite large data sets that might exist that the intelligence agencies apparatus, the Defense Department of the United States might have. I mean, I don't know what those data sets might be, but if they're surveillance data sets, say for example, it was true that every telephone conversation every American has had since the 1970s is actually recorded and stored somewhere. I mean, there's rumors that this, and it's not. It's not beyond belief. It's not beyond the pale, right? I mean, it's perhaps unlikely, but it's not beyond the pale. It's possible. And there, rumors have circulated for my entire life that something like that is going on. If that were the case, that both in its audio form, so quite rich, bit richer data, and then also transcribed into text. Which you would use AI for to do the transcriptions, and then you could use those transcriptions as text data to train larger models. I mean, that could be a competitive edge, because that's a lot of content, that's a lot of data, and it'd be one would assume it would be reasonably high quality data, or at least
I mean, that would just be so insane.
Maybe not.
I mean, keeping
so that's just an example. I mean, maybe you could, in other words, not only could some state actors have an advantage financially because they've just got deep pockets, but there may actually be other resources they have access to that could prove advantageous in training these models. Just gigantic video and audio and text data sets that are not publicly available and not well known. So, I mean, I can imagine, that being the case. And I'm, so yeah, we've been having discussions for 2 years odd now since the ChatGPT moment, and I've expressed the, I guess more cynical suspicion all the way along that state actors have been clawing at getting this, these capabilities into their grubby hands from the very start, probably well before the ChatGPT moment. And it wouldn't surprise me at all that, to discover any level or depth of collusion with the major players. In the corporates, so the big tech companies, and it wouldn't surprise me that if there were fully independent sort of defense or intelligence agency efforts, running in parallel, their entire teams with entire models that aren't public at all. That wouldn't surprise me either. So I think all of that stuff is still potentially on the table. And again, it's because the prize on offer is just irresistibly valuable. So I think if you take the sorts of things we talked about throughout this seminar seriously, about AGI and ASI, superintelligence, then if you take that at all seriously, then it justifies almost anything. Terrifyingly, almost any action or level of investment, for example. So, I mean, if you really do think if you get across the finish line first, you win the world and everything in it. And if you don't get across the finish line first, you lose everything. Well, I mean, when you put it in terms like that, what's justified in terms of action? Anything. So yeah, I mean, sure.
time to move to Mars.
Yeah, so, and I don't. I mean, I have. I don't have confidence that people are all super wise and brilliant and always make good decisions and good judgment calls. I don't think human beings necessarily have a sterling track record in that respect, but I do think that people are generally well intended. So I'm less worried about the scenarios where nefarious, mustache twirling, villainous, whether deep state villains get their hands on this and use it to make themselves rich or whatever. I'm not all that worried about that. It's the recklessness of creating systems that escape our control completely that seems like the bigger risk to me. Anyway, then that circles back to alignment and all the other conversations we've had.
What could go wrong if that system has memorized all the phone conversations of every American for the last 20 years? Like that.
All the Facebook posts and everything, right? What could possibly
no possibilities for blackmail or persuasion. Yeah.
Right.
All right. I guess that's a fitting up note to end on.
Okay, so here's my suggestion is with my book coming out on Sunday. For next Wednesday, I'd like to return to some of the godless transhumanism questions we've talked about in the past. That'd be fun. It'd also be fun to do a review of where we stand technologically with Neuralink and brain-computer interfaces, because that space has evolved in the last couple of years, with some particular, successes now to talk about. So I think it'd be fun to talk about some of those, because those are they're relevant to this contents of the book, and of course AI is in the book too. So we can maybe talk about all that stuff.
Yeah. Very good.
Is that okay?
Well, I'll see you on Sunday, and then here next week.
Yeah, no, awesome. And everybody, all of you guys, if you can, it's, what time is it? It's 3, it'll be 3 p.m. Eastern time for me. What is that, 7 a.m. for you guys in the morning?
That's right, yeah.
Is that right? So, yeah, it's a bit early in the morning. Sorry. It's tough to get a time that works for the entire world. It's really tricky to get North America and Europe and Australia and New Zealand.
Yeah, tell me about it.
It's really tough. But hopefully it won't be too painful. So thanks, Dan, for making the effort early on a Sunday morning. Oh, I guess it's a Monday morning.
I woke up at 5 a.m. this
Appreciate
morning.
it.
7 a.m. is not early.
Okay. All right. Good stuff.
See you, mate.
Thanks, guys.
Bye.